The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, and welcome to the Aculon webinar on the NanoProof series of PCB waterproofing technology. My name is Mario Gattuso. I'll be your host today. I'm the Senior Business Development Manager at Aculon, and I manage our electronics portfolio of products, including NanoProof for waterproofing of electronics and NanoClear for treating stencils. And today we're going to be diving into NanoProof and some of the new testing that we've done. And first off, get started with a video talking about Aculon, where waterproofing meets brilliant.
I need you to waterproof my phone. Okay. Brilliant! Brilliant!
Okay, that was a fun video we did for St. Patrick's Day this year, so we thought that'd be a fun way to kick off the webinar. And with that, let's get started. Let's see, on to the next page. We're going to talk about a few things today. We're going to do an overview of Aculon and NanoProof. We're going to talk about the PCB waterproofing market need, introduce the NanoProof series, discuss different application methods, competitive comparison of other options that are out there, and we are going to go over some case studies. We're also going to do a Q&A session at the end. I will be handling the Q&A session, so I will be reviewing your questions once we're done giving the webinar. So I encourage you over the course of the webinar to type your questions in, and at the end of the webinar we will address them. Just note that I will not be able to review them while I'm speaking, so at the end of the webinar I will address your questions, and I encourage you to fill in as many as you have. Quick overview on Aculon. We are a leading provider of surface modification technologies, mainly focusing on the development and production of technologies which modify a broad variety of surfaces, anything from metals to glass to polymers. Treatments include formulas for imparting hydrophobic, oleophobic, hydrophobic, and also adhesion promoting functionality on surfaces. Majority of our treatments are extremely thin, simple to apply, and require minimal or no application equipment. We currently are working under 3 distinct units: electronics, oil and gas, and specialty, which encompasses all applications that are not either electronics and oil and gas. And today, obviously, we are going to be talking about NanoProof, which falls under the electronics line of products. Our core focus is applications, optimization, materials development, and then we produce and sell the materials for you to apply on your product or in your application. We're located in San Diego. We have distribution in Asia and Europe, and we also can supply directly. Now, to talk about the PCB waterproofing market, it's an emerging and exciting market as it's very large. Pretty much all electronics devices have some need for some level of waterproofing. And we do believe that within 2 years, waterproofing will be a standard feature on a majority of premium devices out there, including smartphones, tablets, and other wearables. In addition, there's other devices in communications, Internet of Things, home-type devices that also benefit from some level of waterproofing, whether it's full immersion or humidity protection. In addition, we also do some work in areas such as medical devices in order to avoid the hassle of conformal coatings. We do have worldwide distribution. CapLink handles our distribution in Europe, and we have several distributors in Asia. So before we get into the product and the applications, what is the exact problem we're solving? By 2020, IDC projects that 1.7 billion smartphones are going to be shipped per year at a value of $400 billion. And more than 900,000 smartphones per day are currently damaged by liquids globally. Breaking down the damage to mobile phones, you can see that it's near a 40-60 split between water damage and mechanical failure, such as a shattered screen or a broken body. So there's a huge opportunity here to eliminate the water damage portion. Further diving in, you can see that 38% is due to splashes, and the rest is due to some sort of immersion. So that definitely gets behind why a large number of suppliers are looking for immersion protection, IPX7, IPX8 levels. So why do we need waterproofing? Well, people are using these devices on a day-to-day basis, and as we all know, they can be very careless. No matter how careful you are, it's easy to drop a device into the sink or a pool or a toilet. And then, of course, devices are exposed to wet operating conditions, whether it's a lab-type environment or simply rain and a humid environment that can cause corrosion over time. One question we get fairly often is what level of water protection do I need? And so this will give you a good idea of kind of what you're targeting, and also maybe set some realistic expectations as to what you really need. Because oftentimes we get people coming in saying, I want IPX7, and for their application, IPX4 or 5 is probably more than enough and is going to be much simpler and lower cost to implement. For example, if you had some sort of device that's, say, Wi-Fi enabled that you're mounting on, maybe the exterior home about 4 or 5 feet up on the wall, you're going to want to have protection from, say, splashing sprinklers or humidity, but full immersion, probably not your biggest worry. If that part's getting immersed, chances are your house is in a flood and you got bigger problems to deal with. So we have some general recommendations around what level of protection is needed. Mobile phones, of course, everyone is looking for IPX7, and those are certainly subjected to immersion conditions, whether falling off a boat or into a sink or toilet. And then getting into many of the other devices, you have spraying water, maybe hearing aids falls under that category. And then splashing water, there's a multitude of applications that kind of fall in the IPX4 or 5 level. So to solve these problems, we have NanoProof, which provides water protection from humidity exposure all the way to full water immersion. These are award-winning products and are implemented in several applications. All of these applications utilize proprietary technology and surpass competitive offerings. They're far easier to use, and in most cases offer quite a bit more robust levels of performance. In addition, the application equipment is affordable and readily available, and we do find that because it uses the same equipment that many traditional conformal coatings are applied with is already in your production environment. So to get into the key benefits of these these products. They can reduce product returns due to water damage. These products are also reworkable. It's very simple to rework them with a little bit of diluent solvent. The coating can be removed, the part can be reworked, recoated without going into a deposition chamber, and then those parts don't need to be scrapped. Huge benefit, something that everyone is looking to get away from, is no or minimal masking is required. In almost all cases, these can be selectively applied, and so the masking and demasking process is fully eliminated, and that's just a huge labor and time saver. These coatings are safe, they're non-toxic, and they can be used in a factory environment, and they're certainly very affordable relative to the other options that are out there. Here we have a chart that breaks down some of the basics of the different NanoProof series products. I'm not going to get into every detail, but a PDF of this presentation is going to be emailed out so you can have a look at it later. We have a wide range of options from NanoProof 1, which goes down fairly thin, around 500 nanometers to a micron in thickness, and offers basic levels of protection, IPX2 to 3, and is extremely easy to apply. We have some mid-level protection options, NanoProof 4 and 5, which are more in the 5 to 10 micron thick range, offer IPX3 to 5 levels of protection, and are great options, very easy to apply. Again, great options for those of you looking for splash and sprayed water protection and some humidity robustness. And then on to 7 and 8.4, also 2.1, which are our most robust coatings. In general, they're 30 to 40 microns thick. They have a special feature that allows them to hold their thickness around the edges of three-dimensional components, and which is really what gives them the edge up on anything else that's out there. So you could have a 30 micron thick coating on the top and on the bottom of your component, and then the edge is not going to vary by more than a few microns. It may be anywhere from 28 to 32 microns in thickness. Maintaining that thickness over the edge is what allows you to get protection. All of the NanoProof coatings come standard with a UV dye. They can also be supplied without a UV dye if that's desired. We do get that request occasionally for some applications. Another nice feature is some of the NanoProof line, not the thicker variants, but some of the thinner variants, can essentially coat the entire device. And there's no negative impacts on coating the antenna, headphones, push buttons, camera, speakers. They're essentially so thin that there's no impact there. But again, that applies to our thinner coatings, not necessarily the 5, 7, or 8.4, which are all thicker than 10 microns. So we'll get into some of the testing here that we've done to validate these IPX7 claims. What is commonly used in the industry is the IPC B25A multipurpose test board. So essentially what's done is this test board is coated at a nominal thickness with whichever coating we're testing. It's then electrically powered up and then inserted into either a salt and sweat solution or water or into an MIR chamber. And then we measure the current leakage while it's under voltage. So you can see here, for example, this is an example of our 7.0 material, which is expected to get IPX7 levels of performance. This has been coated. The board has been powered up at 18 volts. And you can see here over the course of 3,500 seconds, the current leakage was measured. And you can see there's some spikes up to maybe around 200 nanoamps on one of the boards, and the rest kind of stay flat around just under 100 nanoamps of current leakage. And a 500 nanoamp spike is considered the fail threshold. So all of these performed incredibly well. There was no observed corrosion on these boards after exposure to salt water at 18 volts. So this data is available in a new technical paper. So we're going to send this technical paper out to all attendees after the webinar. And the focus of this the technical paper is enabling IPX7 level 7 and 8 waterproofing protection. So this paper gets a bit more into getting beyond the IPCB 25A test board, because this board serves as a nice general proxy to compare the insulation resistance of various coatings, but by no means does it represent real-world results. In the real world, boards have components and 3D features that are far more challenging than just coating a flat board. So coatings which routinely pass this IPC testing will then go ahead and routinely fail the same test when coated on a populated board or an actual part. So we decided we need an updated proxy for evaluating our product's ability to protect real boards, and led to some of the developments we're talking about today. So what we utilized is some very simple LED strips. They are cheap, readily available, extremely sensitive to moisture and water. They will almost immediately corrode and fail on insertion to water if they're not protected. So essentially what we do is coat these strips, dip them in water while powered up, and then evaluate them for failure afterwards. And based on this, we can determine if the coating is capable of offering any sort of real-world protection on the three-dimensional device. We tested a common traditional silicone readily available from a major supplier. Passes the IPC board testing on a flat board with no problem, but failed the LED strip testing. And this was at a very thick, 100 micron thick level. And that's because these coatings, they slump. They have no feature or way to maintain their coverage on the corners, the high corners of the components. So even putting down multiple coatings, if you're not essentially flooding the board to the point where the component is just underneath the coating, it's not going to be protected. Those sharp angles are going to be exposed to water, and you're not going to get IPX7 levels of performance. Your boards are going to fail. We saw the same exact thing with a traditional acrylic and several other coatings. Again, did not protect the edges, slumped, and did not give real-world IPX7 performance, even though it did just fine on the IPC boards. Now getting into the NanoProof Extreme levels of level products, 2.1, 7, and 8.4. All of these pass the traditional IPC board testing, but they also pass the LED strip, and that's because they have a special feature which allows them to actually maintain their thickness around the edges and provide a uniformly thick layer around all the 3D components. The sharp angles are protected, and you get real-world IPX7 performance. And so we'll do another demo video showing how a phone that has been coated using these techniques is able to be inserted into a fish tank and remain fully functional for a half hour. Okay, so now we're going to get into how NanoProof is applied. So there's multiple ways that NanoProof can be applied. Some of the most common are spray, dispense, jet, and also dipping. The coating equipment is readily available for all of these application methods. Many of our customers utilize products from companies like Nordson, Simtech, and PVA. Smaller production parts will often use manual dispensing. More medium-sized volumes will use batch automation or inline automation. And then for very, very high volume, this can be fully automated, hands-off essentially, and thousands of parts can be done on a daily basis. We're going to get into some of the other next generation waterproofing technologies that are out there, and we'll talk about the differences between them and NanoProof. So gasketing is something that has been implemented in products for the past few years now, commonly available from companies such as Henkel. It has an extremely effective initial performance, achieves levels IPX5 and up, even up to IPX7. The large downsides to gasketing are that it's complicated. The board needs to be designed around fitting the gasket into it. Often port plugs are required. And then the biggest problem is that it is prone to catastrophic failure. So if the phone is dropped, or if a gasket fails, and then creating an ingress point of some sort, and that phone is then inserted underwater or falls into water, that ingress point is going to allow water in, that it's going to entrap it inside the phone. It's not going to be able to escape the phone, and you're going to have a certain failure situation. So we're finding that some companies are coming to us looking for either a replacement for gasketing or also as a backup so that they can utilize their current gasketing and know that if the phone is dropped and the gasket is compromised, then they do have protection on the boards. So that is definitely something to think about. Vacuum deposition has been around for a long time with options such as Paraline. It's not necessarily designed for full immersion or waterproofing, so it typically is only going to give you something along like IPX2 to 5 levels of performance. Biggest problem is it's incredibly complicated and expensive. The capital equipment is very costly. Batch processing is very slow, so it's very costly to implement. So for consumer electronics, oftentimes the cost is a no-go. And then in addition, it's very labor intensive just due to all the masking and demasking, because there's no way to control where the coating goes. It goes everywhere. So if you don't want it to coat on a certain part, you've got to mask it. There's really no getting around that. So then we get back to the NanoProof Extreme, the fluorinated options out there. They're going to get you up to IPX7 levels of performance. They are easy to apply. They cover your complex features, and they're very cost effective. The material is typically only going to cost anywhere from 10 to 80 cents to implement on a device. Again, that depends on the thickness of the coating down, how much you're using, the surface area of the coating, and how much of the board you're actually treating. The only downsides are that it can contain solvents that are VOCs. We do have VOC-free options, but there are some that are VOC containing. And then the other thing to keep in mind is that for critical quality control for certain applications, the process can be somewhat optimization intensive and can take some time. So here we have a chart that again compares gasketing to vapor deposition to NanoProof, pretty much summarizing the last few pages. I'm not going to go over this in detail. This will be available in the PDF that we send you If you have any questions regarding this or comparing the options, please do fill them into the question section. So now we're going to get into some case studies. I'm going to talk about Bluetooth headsets, wearables, outdoor home electronics, hearing aids, and also mobile devices. First example is a Bluetooth headset application. The customer came to us looking for protection from sweat and splashing water. They didn't necessarily need full immersion proofing. The requirement was IPX3 with ideally IPX4 level of protection. So in this process, we treated some of their parts and went through some of further evaluations at their site to finalize the process. It took about 6 months, and we ended up selecting NanoProof 4.0. They are currently spraying this product with a PVA valve, and they coat everything excluding the audio speaker. And this passes their IPX4 level of qualification. Next case study example is the coating of wearable devices. Customer came to us looking for protection from sweat and splashing water. They didn't need full immersion proofing. They merely needed to protect from rain and shower exposure, so they wanted IPX4 and IPX5 if possible. So let's see how we did that. So initially we treated some of their parts via spray, and coming back to us, they identified high voltage components which needed additional protection. So from there, we actually went with a two material solution. This took a little over 6 months to implement. We spray the part with one material and then do a spot application of a more robust treatment on the components that indicated a problem. And this achieved IPX level 5 protection for the customer. Another very interesting application is outdoor home electronics. So many new devices coming out on the market for the home that are Wi-Fi enabled, including those that need to be mounted outside and are going to be exposed to splashing water from rain and irrigation equipment. So with these levels of protection, IPX5 was required with a desire for IPX6. Aculon and this particular customer collaborated directly on this application and determined that 5.1 was needed to protect their high voltage components. So excluding the audio speaker and optical components, everything is sprayed utilizing NanoProof 5.1. And because 5.1 does not offer the push-through connectivity while dry, what's done is it's softened with a diluent solvent, and then the electrical connections are made directly through the coating, which has been softened. And IPX5 level protection is achieved on this application. Another great application is hearing aids. We actually do this for a few customers. They need protection from sweat and splashing water. However, full immersion proofing is not required. For this particular application, the customer came to us looking for IPX3 as a requirement with IPX4 as a desire. The customer obtained samples of our treatments and coded and tested them internally successfully and selected NanoProof 4.0. And the application method they're utilizing is a PVA spray valve with excluding the audio speaker. And this passes the IPX4 qualification. And of course, nearly every cell phone manufacturer is looking to achieve the holy grail of IPX7 levels of protection. Some are not currently protecting and need a level of protection. Others are gasketing and are looking for a backup to the gasket in case of failure. So we're currently directly collaborating with several cell phone manufacturers working towards IPX7 levels of success on the board. These are ongoing projects and are currently working with NanoProof 7 and 8.4. In most cases, they are only looking to apply to certain areas on their components, so we're using a selective deposition process utilizing the Nordson IntelliJet. And we'll keep you updated as this work progresses. So to summarize, NanoProof waterproofing option offers high levels of performance, achieving IPX7 and greater, continuous production, extremely fast cycle times, no cures required, no masking, no demasking, no batch processing, and push-through connectivity, which is the ability to make the connection, electrical connections, after the treatment and drying of NanoProof, which eliminates intensive masking and demasking on connectors and also offers a level of protection on that connector itself. Also, the ability to rework. The treatment can be removed with a diluent solvent, allowing the board to be reworked. Parts that have been treated with parylene or conformal coatings in most cases need to be scrapped if there's a problem, because you cannot remove the conformal coating or parylene which has been cured on the board. So that's a huge cost savings that after the treatment with the Aculon part, the part can be reworked and reinserted back into the work stream. There's a few ways that Aculon will work with you on your application if you're interested in evaluating. First of which is just a simple customer trial, in which case the customer would buy samples of the different products to test and would then internally run tests on those products, coming back to Aculon looking for feedback or for advice. We found that it's better when we actually work directly with your parts. We have a good deal of experience applying these coatings and evaluating different applications. So if we can get your parts and then we can apply them to your board and make sure they're properly applied and at the right thickness, we can get them back to you for electrical testing. And then based on there, we'll look at what the next steps are. And even better is if we can directly collaborate and come up with a plan to determine the best solution for your application. We'll work directly with you to set up a DOE, do some initial evaluations, review the testing results, and then iterate from there. So in summary, Aculon is a leading supplier of nanoscale repellency technology. We have NanoProof qualified in production on numerous applications. NanoProof is easy to apply and cost-effective and provides numerous options based on your level of performance required. Also, NanoProof outperforms the competitive technologies, traditional conformal coatings, and vacuum deposition, and Aculon supplies NanoProof globally. So now we'll get into questions. So I'm going to open up the questions section. And if you have any questions, please fill them out. Let's see. Okay, so I see the questions coming in. Just a second. Okay, we have a lot of questions. All right, let's get started. First question is, what is the abrasion resistance and UV resistance of NanoProof 7? So the NanoProof series of coatings is not necessarily designed to be abrasion resistant. So part of the way these coatings are able to be reworked is because they don't cross-link. And so because they don't cross-link, they're not necessarily as robust as, say, a fully cured epoxy. So there's certainly a trade-off there. You're not going to have that abrasion robustness of an epoxy, but you're going to get reworkability. And traditionally, these are going to be contained within some sort of a case. They are certainly robust enough to handle and accept any normal amount of handling. So in most cases, it's okay. They're not necessarily intended to be used on parts that are exposed to the elements or to significant abrasion. The other question is, what is UV resistance? Again, these are not intended for application with direct exposure to UV. It's possible, so we have not tested that. It's possible they have good UV resistance, but it's not something we've looked at before. Let's see. Next question, which touches on what I just talked about somewhat, is how susceptible is the coating to wear during handling and assembly? So that's not an issue. They can be handled during assembly just fine. They're not susceptible to wear unless they're being extremely aggressive with the coating. Next question is, how susceptible is the coating to chronic immersion? Will it eventually dissolve? No, these coatings, none of these coatings are soluble in water, so no, they will not dissolve due to exposure to water. They would need to be either abraded away in some manner, or some sort of incompatible chemical would have to contact them. Let's see. Next question is, can you talk about coating for PCBs to be autoclaved? So we've had some customers do some autoclave testing. I don't have that data shared with me. In most cases, these coatings will survive up to 225 Celsius. So autoclaving should not be an issue. Let's see. Next question is, again, heat related. How susceptible is the coating to heat? Say, for example, 50°C for long periods of time. Again, these coatings are stable at 225 Celsius for long periods of time. So 50°C, 100°C should not be any issue whatsoever. We have some applications where these coatings are put through low temperature reflow after application. Next question is, what is the contact angle of these coatings? That's a good question. So for water in general, these coatings are going to be anywhere from probably 100 to 115 degrees contact angle, and then depending on the coating, they're either not going to have oleophobic properties, or they're going to be oleophobic around 80, 85 degrees. Again, these are a line of products. All of them are different formulations, so they're going to have their own behavior. There's more data on the website. We will email you afterwards if you have further questions on that. Let me know. Next question is, please explain again why masking is not needed. So masking is not needed because these coatings are applied via selective deposition. So you utilize a dispense or a jet or a piece of equipment that only applies the coating where you want to put it. So by using selective deposition, you are avoiding the areas where you don't want coating, rather than masking and then putting coating everywhere. Next question is, can you post this presentation? So yes, everybody who has attended and registered is going to get not only a copy of the PDF presentation files, they're also going to get a recording of the coding. So everybody's going to get a copy of this afterwards. Next question is, does the coating affect contacts in the connectors? And that's why there are no masking requirements. So yeah, so to touch on the masking question a bit more, there's also no masking on the connectors because these coatings offer what we call push-through connectivity. You can coat the connector, let the coating dry, and then you can literally make the electrical connection, whether it's a flex connector or some other type of connection, when you're assembling the device, and that connector will be protected by the coating, and you'll also have full functionality of your connector. Next question is, what solvent will work for rework? So each of these different coatings, depending on the chemical makeup, is going to have a different solvent. So that's on a case-by-case basis. In most cases, it is the exact same solvent that the coating is carried in. So whatever solvent the coating you are utilizing is carried in and is evaporating when the coating dries is the same solvent we would supply for reworking. Next question is, what is the cost per square inch of board? That's a good question. few things to consider when it comes to cost is that your cost is going to depend on whether you're coating the entire board or just selectively coating components, which coating you've selected. Naturally, there's a variation in cost between the different options, and then how thick of a coating you're putting down. But in general, you'll find that if you were coating, say, a 3x5 board on both sides, you'd be looking at anywhere from 10 to 80 cents per board, and that depends on which coating, how thick, and how much of the board you're actually treating. Let's see, scrolling down the questions here. Let's see, next question. Will adhesive stick to the PCB with an Aculon coating on it? That's not something we've looked at before, but it's possible. It's certainly not recommended, though. These coatings are most of them are repellent in nature, are going to have lower surface energy, and are not going to offer a very good, robust adhesion. Next question is, will liquid or gel fluxes used for touch-up and rework of solder joints dissolve or damage the waterproofing coatings? That's a good question. That's really going to depend on what the solvents contained within the gel and liquid flux are. So if they are compatible, if they are going to dissolve the coating, they certainly will. If they're not compatible, then they won't. If that's a desired effect, well, we can recommend a diluent solvent that will clear the coating away there. And if it's not, we can certainly advise, depending on which coating you're using and the chemical makeup of your liquid or gel flux, what the expected result can be. Next question is, what's the criteria for what materials the NanoProof series can be applied to? So the NanoProof series is essentially substrate agnostic. It can be applied to pretty much any substrate. So it'll apply to glass, to metal, to plastic, which is what makes them perfect for application on the PCB board. Because as you can imagine, there's many different substrates making up a PCB, mainly polymers and metals of some sort. Another question on temperature. What temperature are they good to? We don't recommend that you take any of them higher than 225 Celsius. So they can be put through low temperature solder reflow, but we wouldn't recommend necessarily a full temperature reflow. Another question is, I'm using a JST type connector. It seems I could just spray this on and then plug in, scraping the coating off for the connection. So yes, that's correct. That is essentially how the push-through connectivity works. You can spray your connector and then you can make the connection, and the prongs will push through the coating and make a connection. Next question is, how do you handle open connectors and keep out areas in traditional conformal coating systems? If you're talking about the equipment, then you would just selectively apply not to coat those areas. Next question is, have we measured the water vapor transmission rate? Yes, for some of the coatings we have, and that data is on the website. If there's a specific coating you're interested in, send me an email. It's listed on the page here, and I can elaborate further. Another good question is, what are the cleanliness requirements of the substrate before applying the coating? So we recommend that the substrate is generally clean. So it doesn't need to be critically clean. You don't need to plasma clean it in most cases, but also it shouldn't be dirty. It shouldn't be covered in clear, visible contaminants. You definitely would not want to apply it over a no-clean flux. We get that question a lot. Can I just leave the no-clean flux and apply it over the no-clean flux? And the answer is no. we've done significant testing on coated boards without any flux on the board and over no clean flux, and the no clean flux boards perform terribly. It really makes it extremely difficult to get the same level of protection. So we recommend you do clean your boards if they have flux on them. Let's see, what other questions do we have? Next question is, what solder types are preferred prior to Aculon coating? We don't have any preferred types. It's worked with everything that we've tried before. Again, we do recommend that the no clean flux is removed prior to application. Then I got a follow-up to autoclaving. Thanks, but autoclaving is also under pressure along with temperature. Yep, pressure is not going to have any impact on these coatings. That's not a concern. Next question is, what is your selective deposition edge definition? So that is actually a better question for one of the applications companies, such as Nordson Simtech or PVA. They have much better ideas on how much control they have over putting down coatings. Next question is, spraying fully automated or can it be done manually? In this case, would you need masking? So it can be done manually. I mean, this is a liquid application process. There's no reason you can't do it manually, and there's no reason you can't do it automated. And then as far as masking goes, that depends on your application. Can you manually coat the board so that you coat where you need and don't coat your keep out areas? If you can do that, then no, you don't need masking. If you can't do that, then you either need to figure out a manual automated process or you need a mask. Next question is, could we spray an entire board including solder pads? Then since the coating degrades with heat, could we solder through it on the pad? You could certainly try. That's not something we've looked into. It might work. So for the person who asked that question, shoot me an email and we're happy to work on that project with you, but that would be some new testing. I got a question here. A rule of thumb based on IPC conformal coating handbook is 2 to 3 mils. How do you apply this material to achieve this requirement? So we're throwing out that handbook here. That's for old coatings. That's old knowledge. You do not need 2 to 3 mils to achieve the performance we're talking about. So we're not talking about applying multiple layers of coatings. The reason you need to do that is because those materials slump and don't coat the edges. So these are a different class of material, and I would not use those recommendations for applying the coating. You do not need that much material. Next question is, how long does it take for a full cure? Most of these are extremely fast-drying solvents. So they are dry usually within 10 to 15 seconds and fully cured and dried anywhere from 5 to 20 minutes. And the next question, and looks like the last question I have so far, is it says, most military customers can't switch their process without requalifications. How do you overcome this? That's another good question. Unfortunately, the level of testing that is required for military applications and the volume that military applications are treating is quite low. So at the moment, we're not testing these materials out to the level that the military customers are looking for. Most of these are more geared towards consumer electronics. If a military customer is interested in pursuing the testing to qualify for their application, we'll certainly work with them, but at this point, that's not something we're necessarily pursuing. So So if anyone has any further questions, let's see. Okay, some more questions coming in. Let's see. Okay, there are definitely more questions in. Just a moment. Okay, so next question is, what are the cure conditions and how long do you need to fully cure the polymer? So these are room temperature, air dry cures. So some added heat and airflow will hasten the dry, but typically they're handleable in less than a minute and fully cured within 5 to 20 minutes. Next question is, how conductive are these coatings? These are non-conductive coatings. They need to be insulating by nature. So the coating, if you're asking about conductivity based on the push-through connectivity, it's because the electrical connection goes through the coating, not because the coating transmits the current. Another question, do you have thermal conductivity data? Yes, on some of the coatings. Send me an email on which ones you're interested in. If we have that data, I'll send it to you. Another question on cleaning and no clean flux. Let me just reiterate, no, you do not want to apply onto no clean flux. It needs to be free of no clean flux. It's not an adhesion concern. It's a performance concern. The coating is not going to perform well if you apply over no clean flux. Let's see, going through the next questions here. I've got a bunch of repeats, so I'm just trying to dig through to avoid the repeat questions. Next question is, what product do you recommend for coating a polypropylene or polyethylene bottle? That's not relevant to the NanoProof coatings we're talking about. We can certainly coat a PP or PE bottle, and what coating we would recommend depends on what you're looking to achieve. So send me an email and I can talk to you about that. What product? So next question is, does vacuum have any effect on the coatings? Will they evaporate or migrate under vacuum? That's not something we've evaluated. So no, we have done no testing. We don't have any customers who are looking to put their parts under vacuum. So it's not something that we've dug into, but we certainly don't anticipate that vacuum would cause any evaporation or migration. But again, that hasn't been studied in detail. Next question is, any cosmetic change on coated surface? So yeah, you will see these coatings are in the typically 5 to 40 micron thick range. So you will see that there's a coating. They all have a UV dye in them. So you will see the UV dye on the board. Next question is, where can I get a copy of the Aculon white paper? We'll be emailing that out, and we'll also be posting it on our website shortly. Let's see. A few more questions I'm sorting through. I have a question here. Can you comment on the amperage leaking during saltwater testing? I'm not sure exactly what you're talking about. So for the person who asked me, I'm commenting on the amperage leaking during saltwater testing. Please send me an email with maybe some more specifics, and I can connect you directly with the chemist who did that testing. And then I have a question, are there any plans to supply the electrical data for NanoProof 7 that's available for the competing products? Yeah, there's data in the white paper. So the data that was put onto this presentation is just a tidbit of data that is available in the white paper. So please refer to the white paper. And with that, it looks like that wraps up all our questions. So we're going to close out the webinar. So thank you very much for attending. Your excellent questions. Really appreciate it. If you have any further questions, my email is there for you to view. Shoot me a note and we'll be happy to help you out. Thank you again so much for your attending and your interaction.